Let's have a look at the volume and surface area of a cylinder. Now, a cylinder is a very special type of prism. Okay, so if you recall, a prism is a shape that has the same cross-section all the way through. So something like this, this cylinder here, it's really a circle, or a circular or circle-based prism. So wherever you cut this cylinder, it's going to be the same shape throughout. And the volume of a cylinder, just like any prism, is AH, so area of the base or the cross-section times the height, right? This is the A from the, if you recall, V is equal to AH. Okay, so the A happens to be a circle, pi r squared. Let's look at an example. So we have a cylinder, diameter is 2.4 meters, and the height's 2 meters, and we want to find the volume of the cylinder. Okay, so volume is equal to pi r squared h. We need the r. Okay, so we're given the diameter. We do not work with diameters. We work with a radius. Okay, so that's going to be 2.4 divided by 2, and the radius is going to be 1.2 meters. Okay, so volume is equal to pi times 1.2 squared times the height, which is 2. Okay, and let's enter that in and see what we get. So let's put in pi times 1.2 squared times 2, and we'll round this to 2 decimal places, so that's going to be 9.05 square meters, okay, which is around 9 kiloliters, which is around a bit over 9,000 liters. Okay, now let's have a look at the surface area. Okay, so we assume what we call a closed cylinder, okay, or the same thing for any prism for that matter. When we're trying to find the surface area of any prism or a cylinder, unless otherwise stated, we just assume it to be closed. Okay, that means it's got the lid on both sides, and the formula for that is 2 pi r squared plus 2 pi r h. Now the 2 pi r squared comes from the two circles of the net of the cylinder. Okay, so if you remember, if you were to sort of get a cylinder and then sort of fold it out so that you have it sort of laying flat, there's two circular ends, so that's the base and that's the lid, and this is the curved surface. This is what I call the label. Okay, so if you wrap like a piece of paper around, imagine this pen as a cylinder, imagine you were to wrap a piece of paper all the way around it perfectly, okay, it'll fit perfectly around this circle, and that's the circumference of the circle, which is 2 pi r. Okay, so the label or the curved surface, the area of that is 2 pi r, because it actually wraps around the circle, multiplied by h, and that's where this 2 pi r h comes from. Let's have a look at a couple of examples. Find the surface area of the following cylinders. Okay, so the first one doesn't state anything whether it's open or closed, so we're going to assume the lid and the base are there, and you're just given the radius, so 1.2 meters times the height of 2.4. Okay, so area, okay, is equal to 2 pi r squared, because we've got the two circular ends, so 2 pi times 1.2 squared plus 2 pi r h, so 2 pi times 1.2 times 2.4. Okay. You could work them out separately if you like and add them together, but you just got to be careful that you don't get rounding errors. I just work it all out at once. I just think it's a little bit quicker. So 2 pi times 1.2 squared plus 2 pi times 1.2 times 2.4, and we get 27.13. Sorry, 14. 27.14 square meters, and we're just going to round that to 2 decimal places. All right, so let's have a look at this last one here, part B. That's open at one end, and we're given a diameter. So the radius is equal to 3.6 divided by 2, and that's going to be 1.8 meters. Okay. Now, because we've only got one end, instead of it being 2 pi r squared, it's just going to be just pi r squared, one of those. So area, okay, is equal to pi r squared, so pi times 1.8 squared, okay, plus 2 pi times the radius, 1.8, times the height or the depth, okay, which is 4 meters. So entering that in, so instead of 2 pi, it's just pi times 1.8 squared plus 2 pi times 1.8 times 4, so that's the height of the cylinder, and that's 55.42. And we'll just sort of leave it in square meters, so 55.42.